but I'll be on it always, always.
Hi, welcome back to the Pink Chemist. So today we are going to go over the box method to balance equations. Okay, so in this video we will go over box method balancing equations. But before we get into doing examples, I first want to give you a few steps to take note of. Okay, so the first step is that if you have any chemical word problems, you're going to convert. Okay, you're going to convert those word problems, those chemical word problems, to skeletal equations. And we've learned in our previous videos that a skeletal equation is an unbalanced equation. Okay. Okay. So this is very important. So we want to go ahead and turn those word problems into skeletal equations. Step 2, okay? You want to go ahead and draw a line at your arrow or your yield sign, and you want to separate your reactants from your products. Now this is very important because this is going to help us to see what we are working with. And for me, when it comes to balancing, it is very important for me to see everything that I'm working with. Okay. Now, when you get to a level of mastery, there's certain things that you can really kind of skip when it comes to these steps. But until we get to mastery, we're going to follow these steps. Okay. Step 3, you're going to write up each formula broken down into types of elements. Now, this is a very important step. Now, all the steps are important, but this is very important because if you do not know how to properly identify the different types of elements that you're dealing with in your chemical equation, that's going to be a problem, okay? Step 4, you're going to box up each formula broken down. Okay, let's go ahead and go to step 5 over here. Uh-oh. I don't know why. Okay. So, So step 5. I'm having some technical difficulties here. All right, so step 5. I don't know why it's not as big. Okay, so step 5 is now when you're going to add up. Okay, you're going to add up. So when you're adding up, you're going to make sure that whatever is on the reactant side, the number of atoms on the reactant side is the same number of atoms on the product side. This is very important. Okay. And then lastly, you're going to count up the number of boxes that you have to get your coefficient. Now this is key because you cannot change your subscripts at all whatsoever when you are identifying how to balance your equation. You can only change your coefficient, okay? So this is important. Do not, let me put this here. Do not change subscripts, period. You cannot do it. Point blank, period. manually change coefficients. That's it. That's law. All right. So I hope you got these steps down. So let's get into. So next up, we are going to do an example. Now remember, we are doing the box method. So please make sure that you are taking notes as to what steps to take when it comes to doing the box method. All right. Now you can also notice that I am leaving room and space for my coefficients to go in front of my compound. All right, so the first step is to convert any chemical word problem into a skeletal equation. In this example, that is not an issue, so we are going to move on to step 2. So step 2 is to go ahead and draw a line at our arrow. So we went ahead and drew a line at our arrow to separate our reactants from our products. Now step 3, we have to write up and separate our elements. So here I'm going to go to Na, and I see that I have a subscript of 1, so I'm only going to write Na once, and I'm only going to write I once because I have a subscript of 1. Now when I come to the next compound, I have 1 Ca, and then my coefficient is 2 for Cl, so I am going to write Cl out twice. All right, this is very important for the box method so that you're able to see what you're working with. Now when I come over to the product side, I have 1 Na, and I have 1 Cl, and then I have 1 Ca, and I have 2 Is, 2 iodides. All right, so I went ahead and I have now separated my elements. So for step 4, I'm going to go ahead and box them up. Okay, it is very important that you understand that you must keep each element that you have separated up under the same box if it is a part of the same compound, because if you put it in separate boxes, it will be wrong. Our boxes are very important into how we get our coefficients. Okay, so next, now we're going to read our equation from left to right. As we read it from left to right, we're going to start with Na. Okay, so Na, all right, I have 1 Na on the reactant side, and I have 1 on the product side. So far I'm good. Now I'm going to go to my next element, which is I. I have 1 I on the reactant side, and I have 2 on the product side. So since I have 2 on the product side, and I want my elements to be the same on the both sides, I now want to get another iodide, and in order to do that, I cannot just write I and box it up. Whatever is in that box with I, they have to stay together. So this Na, in order for me to get that I have to also write Na. And once I do that, I'm going to go ahead and box that up. That is the only way that I am able to get that iodine. Okay, you cannot unseparate your compounds like that. Okay, so now I have my 2 I's on my reactant side, and I have them on my product side. However, when I made that move, we noticed that our NAs went up on the reactant side. Okay, so as a result, I got to go back and I got to fix that for my product side. So in order to get 2 NAs on my product side, like my reactant, I'm gonna go ahead and write NaCl. So you notice how if I need one of the elements that's in the box, I have to write every element that's inside that box in order to get that element. That is very key and it's very important because you will look up and notice that your balancing, once you take care of it from left to right, you will notice that it has taken care of itself. Okay, so now I have my NAs on my reactant side, my 2 NAs on my reactant side, and my 2 NAs on the product side. So now I'm gonna go to my next element, which is Ca. So I have 1 Ca on the reactant side, and I have 1 on the product side. So I'm good there. And then as I see, my Cls, I had 2 on the reactant side, and now I have 2 on the product side. So I am now all balanced because all of my elements on the reactant and on the product side, they all equal to be the same thing. So now in order to get my coefficients, I have to count up my number of boxes for that compound. So for NaI, I have 1, 2. I have 2 boxes. So my coefficient for NaI is going to be 2. For CaCl2, I only have 1 box. So my coefficient is going to be 1. For NaCl, I have 1, 2. I have 2 boxes, so my coefficient is going to be 2. And for CaI2, I have 1 box, so my coefficient is going to be 1. All right. Now, what's important to note is that this coefficient, we are using distributive property. So this coefficient, all right, I am really multiplying it by that subscript. Okay. Now, when there is no subscript there, we know that it is 1. So 2 times 1 is 2. So that lets me know that I have 2 NAs. Does that make sense? I got 2 NAs. Y'all see that in my box? I do the same thing. I have to distribute this 2 because it's in front of Na and I. So I also have to distribute this 2 to the I subscript, which is 1. So 2 times 1 is 2. I literally have 2 iodines. Do y'all see what's happening here? I have to do the same thing for the next one. My coefficient is 1. So I am going to take the coefficient 1 and multiply it by the subscript 1 of Ca. And as you can see, I have 1 Ca. Same thing with coefficient 1. Multiply it by the subscript 2 that's next to Cl. And as you can see, I have 2 Cls. And the same goes on for all of the rest of the elements. Okay. So I hope that makes sense when it comes to the box method. Now, I'm going to go ahead and do another example. Okay. Let's do another example. Okay, so we have magnesium plus oxygen gas yields. Okay, I ran out of space. I wrote that too big. Let me try. Let me write it smaller. So I have magnesium plus oxygen gas yields magnesium oxide. Okay. So now when we go to this, we go where step 1 is important, because now we have a word problem that we now have to convert into a skeletal equation. So that applies here. So in order to do that, what we're going to go ahead and do, magnesium, we're going to write the symbol for magnesium, which is Mg. So we got our Mg plus oxygen gas. We know that oxygen gas will convert to O2, yields magnesium. Magnesium has an oxidation number of positive 2. Okay. And oxide is oxygen, and it has a oxidation number of negative 2. And I know that I have to do the process that's called swap and drop, because when I have a metal and a non-metal, which is an ionic bond, I have to swap and drop. So then I am going to have Mg plus O2 yields MgO, because I know that when I have 2 of the same oxidation numbers, they cancel out to simplify to be 1. So my subscripts are going to be MgO. All right. Now, let's go ahead and get into step 2. Step 2. I didn't leave any room for my coefficient. Okay. So that's the room for my coefficient. All right. So step 2, I'm going to go ahead and draw a line. I draw a line, and now I am going to separate my elements. So I got 1 Mg and I have 2 O's, so I wrote them out. 1 Mg and 1 O. Step 4, I'm going to go ahead and box up my separated elements. Okay. So I box them up. Now I read my equation from left to right. All right. So I have 1 Mg on the reactant side and I have 1 on the product side. I'm good right there so far. Then I go to oxygen. I have 2 on the reactant side, but only 1 on the product side. As a result, I cannot just write O and box it up. I have to write everything that's in that box with O in order to get that O. So I have to add that Mg. Okay. So now I have my 2 oxygens, but now my magnesiums have went up on the product side. So now I got to go back to my reactant side and add an Mg. Because in order to be balanced, I have to have the same number of each element on both sides. And so now my elements are even. I have my 2 Mg's on both sides and I have my 2 oxygens on both sides. And in order to get my coefficients, I have to add up my boxes. So for Mg, I have 1, 2. I have 2 boxes. So my coefficient for Mg is going to be 2. For oxygen, I have 1 box. So my coefficient is going to be 1. And for MgO, my boxes are 2. So my coefficient is going to be 2. And now we are balanced. And we're good. Okay. Now I'm going to do a bit of a more challenging example. Okay. We'll do a bit of a challenging example. So let me give myself some room here. So we have AgNO3 plus CaCl2 yields AgCl plus CaNO3 and 2. Now this one I really want you to take your time with, because as you can see we have some polyatomic ions and it's just a lot going on. So we know that step 1 is to convert any chemical word problems, and in this instance we don't have any word problems, so we're good. We already have our skeletal equation written out, our unbalanced equation. Step 2, we're going to go ahead and draw the line from the arrow to separate our reactants from our products, okay? Next, we're going to go ahead and start separating our elements. So over here I have 1 Ag, I have 1 nitrogen, and I have 3 oxygens. Y'all see what happened? I was able to identify how many of each atom that I have by looking at my subscripts. We know again that if there's no subscript there, it means that it is just 1. Okay. Then I'm going to go to my next compound. I have Ca and I have 2 Cl. So I'm going to write Cl out twice. I'm going to go ahead and come to my product side. I have 1 Ag, 1 Cl, and then I have 1 Ca. And this is where things get a little bit tricky, okay? So with my polyatomic ion and I have this subscript 2 outside of my parentheses, I know that with distributive property, whatever is outside of my parentheses, I have to distribute it to everything inside. And what I mean that I'm distributing it to, I am distributing it to the subscripts. So this 2 is going to be multiplied by that 3. And it's also going to be multiplied by the 1 for nitrogen, okay? So in order to do that, I now know that 2 times 1 is 2. So that means that I am going to have 2 nitrogens, okay? And then I know that 2 times 3 is 6. So I'm going to have 6 oxygens. 1, 2, 3, 4, 5, 6, okay? Now, I know that it's a lot of work, but it is completely worth it to make sure that you get the right answer. So my suggestion is that you take your time. Don't rush. So now I'm going to go back and I'm going to go ahead and box up my compounds. Everybody see that? All right. So again, I read my equation from left to right. So as a result, I am going to start with Ag. I have 1 Ag on the reactant side and I have 1 on the product side. So far, so good. Okay. Now I'm going to go to N. I have 1 N on the reactant side, but I have 2 on the product side. So as a result, I am going to go ahead and add another N on the reactant side. So I'm going to do Ag, N, and remember I have to add everything that's in that box in order to get that second nitrogen that I want on my reactant side. So now that I got my second nitrogen, okay, now my Ags have went up and so did my Os. But because I'm reading from left to right, I am only going to go in the order that I started with. So now that my N's have went up to where I want them to be, I'm going to go back to my Ags. So my Ags went up, so now I'm going to come to my product side, and I'm going to go ahead and add an Ag over here so that my Ags can match up. Okay, so my AGs match up over here. I got my AGs. Now my AGs and my ends, they're good. All right. So now I'm going to look at my oxygens. I got 1, 2, 3, 4, 5, 6 on the reactant side, and I got 1, 2, 3, 4, 5, 6 on the product side. I am Gucci. I'm good right there. Next, I'm going to go to my CAs. I have 1 CA on the reactant side, and I only have 1 on the product side. I'm good there. And then lastly, I have my CLs. I have 2 CLs on the reactant side and 2 on the product side. So just like that, I am already balanced with all of my elements on both sides, okay? So now I'm going to go back and I'm going to count my number of boxes to get my number of coefficients. So for AgNO3, I have 1, 2. I have 2 boxes, so my coefficient is going to be 2. For CaCO2, I only have 1 box, so my coefficient is going to be 1. For AgCl, I have 1, 2. I have 2 boxes, coefficient 2. And then for CaNO3, 2, I have 1 box, so my coefficient is going to be 1. And now we are balanced. And we're done. And that is the box method. Alright? If you don't like the box method, see me in my next video for the counting method.
Don't play with it, don't be dishonest. Ay, still not